I haven't heard the Turku Cathedral clock yet, but maybe it is time to start. So, welcome to the UBC Talks webinar about upcoming changes in wastewater treatment. My name is Lotta Lehti. I'm a project coordinator at the UBC Sustainable Cities Commission. I will be your host today together with my colleague Mariia Andreeva. So, how can we reach a new era of a toxic-free water cycle? We will hear answers to this question in a minute, but first I will tell a bit about UBC, about this webinar series, and about the EMPEREST project. So, Union of the Baltic Cities is a network of around 70 member cities in the Baltic Sea region. It was established in 1991 and it works through 8 thematic commissions focusing on different sectors of the city life, like education, health, culture, safety, and so on. In the Sustainable Cities Commission, we work together to support the sustainable development and green transition in cities, as well as address cities' adaptation to climate change. Our secretariat is hosted by the city of Turku in Finland. In our work in Sustainable Cities Commission, we help cities to exchange experiences and best practices so that they can progress further. We are also active in international projects, such as EMPEREST, which is on the focus of today's webinar. And we do a lot of communications. So this UBC Talks webinar series addresses sustainability topics in regular editions. These webinars are organized 4 or 5 times a year. The webinars are open and you can always find recordings of the previous editions on our website and register also for other upcoming webinars. In the UBC network, our commission coordinates the Sustainability Action Programme, or SAP, a guiding document outlining the goals that our network aims to achieve. The current program looks until the year 2030. The Sustainability Action Programme focuses on 5 topics selected as the most important in this decade: resource efficiency, water, mobility, biodiversity, energy, in addition to the cross-cutting issue of climate change. So, indeed, water protection is one of the top priorities identified in our Sustainability Action Programme. And it's with this priority in mind that we have built this project called EMPEREST. I will now tell you a bit about the project, which is on the focus of our webinar. And the aim of this project is to reduce the amount of organic micropollutants in the water cycle. So EMPEREST is funded by the Interreg Baltic Sea Region Programme. It's a big project with a budget of 5.5 million, and we have 14 partners, as you can see here. We have universities, wastewater treatment plants, HELCOM, associations, and the city of Riga. We are now in the 3rd and final year of our project. And what we do, we have this, what we call holistic approach to the elimination of micropollutants and especially PFAS. So PFAS are the forever chemicals used in, for instance, Gore-Tex and Teflon. Our first activity strand focuses on mapping the current situation of PFAS pollution in the Baltic Sea and the catchment area. The results are already available in our project website. Secondly, we are building a tool for cities and water utilities for identifying the PFAS pollution hotspots in their area and to start mitigating the pollution. Third, and this is the focus of today's webinar, we are testing wastewater treatment technology. The driving force behind this part is the update of the Urban Wastewater Treatment Directive. Our piloting results will offer wastewater treatment plants in the region some results and information which will be useful when they plan their own investments in order to meet the new requirements. Finally, we are also building a training package a package of materials for raising awareness. You will hear more about this later today. And we also do communication campaigns in order to raise awareness on the topic. So just to show you who we are. So here you can see some members of the consortium visiting the local wastewater treatment plant here in Turku at the beginning of the project. And here are some photos of sample taking from last summer. The samples of water and fish were analyzed in laboratories, and the results were then included in the report of PFAS pollution in the Baltic Sea region. And here are some photos of our mobile containers being transported. So you will hear more about these containers and what they have inside them in the presentations that follow. So here is our agenda for today. First, we have a keynote presentation from the Executive Secretary of Coalition Clean Baltic, Mikhail Durkin. So Coalition Clean Baltic is a prominent non-governmental organization protecting the Baltic Sea and uniting different actors in the region. So thank you very much, Mikhail, for agreeing to set the scene for us. What are micropollutants? Why should we worry about them? And what's new on the European regulation level? And then after Mikhail's presentation, we will hear from EMPEREST partners. Taavo, Tenno, Marlen, Taggu, Marek Swinarski and Piotr Miakoto will present the EMPEREST mobile containers, testing different wastewater treatment technologies. After that, Vanessa Ingold will tell us about the training materials that we have built in the project. And finally, Mariia Andreeva will tell about the solutions we offer and how you can participate. Before I give the floor to Mikhail, I would like to say that throughout the webinar, you can send your questions through the Q&A box that you see there. We will answer your questions at the end of the webinar, but if there is time, we can also take some very short questions between the presentations. Also, I would like to remind you that the webinar is being recorded and the recording will be available on our website next week. So now it's time to hear our first speaker, Mikhail Durkin. The floor is yours.
Thank you very much, Lotta. And I hope I can share. Yes, just a second. Hello, everyone. It's actually a pleasure being here. And many thanks to Lotta already introducing myself. I don't need to do that again. And indeed, I am representing Coalition Clean Baltic, which is a network of 27 environmental NGOs from 11 countries of the Baltic Sea region. And I just realized that we were established even before UBC in 1990. So we are celebrating our 35 years this year. And we are working in different fields, but I will not dwell on that, given that it is a limited time of this webinar, and I will focus on what I was invited to talk about, and that is impact of micropollutants on aquatic environment and the European regulatory advances. But before I'm going into the slides that I'm happy to present to you, I actually realized also that I was in a similar setting almost 20 years ago with other Interreg projects just starting and actually addressing at that time nothing about hazardous substances but nutrients. And it was, again, a lot of practitioners from wastewater treatment plants, and I am very, very happy to see that now there is a new shift and, well, I would even say perhaps new generation of experts coming to work on hazardous substances from wastewater treatment plants as well. And in my presentation, I will try to explain why. And in fact, also on this slide, you see the image that for you perhaps may not resonate exactly why micropollutants and all those items that are presented here. But basically, this is about all the content in those bottles and jars, but also all different pieces and particles that are coming out from those bottles and jars within their life cycle. And all of that contributes to micropollutants, and I will explain you why and how. So what are the micropollutants and why they are important? And there are plenty of different definitions, and you can find the definition of micropollutants even in the Urban Wastewater Treatment Directive, in the revised one right now, but I will not quote that. Basically, micropollutants can be defined as anthropogenic chemicals that occur in the aquatic environment well above a potential or, well, natural background level. In many cases, you cannot say that there are natural background levels for those substances because those are synthetic. And they are recognized and characterized due to their presence in so-called trace amounts from micrograms per liter to less than nanogram per liter among different environmental matrices and also in living organisms in biota. And those are coming from different sources and pathways, but basically there are several of the categories that can be named that are contributing to micropollutants, and those are pharmaceutical residues from medical treatments, and those are either directly discharged from medical institutions like hospitals or excreted by humans. As well as pesticides and their metabolites, which are used in agriculture to protect crops. And sorry, about pharmaceuticals, not to forget, this is not only about human pharmaceuticals, but also veterinary. And then the third category is personal care products. And those are used daily by all of us, like shampoos or shower gels or deodorants and other types of cosmetics. Unfortunately containing different types of micropollutants, not only microplastics that are mentioned here separately. Different kind of industrial chemicals, and those are discharged during manufacturing processes, as you can see also on the right-hand diagram on the slide. And those are mostly point sources. Sorry, here's my cat. And of course, microplastics, as I already mentioned, and those are degradation products of different plastics and synthetic fibers that are used. And actually, one important point to remember that it is not only about the plastic jars and plastic bottles, it's also about textiles. It's also about our clothing. And finally, heavy metals in trace amounts. And those are cadmium, lead, and arsenic, for example. And those, again, are coming from different sources, including, for example, fertilizers. And I will not explain any further about the diagram on the right, but what is important to say is that there are different pathways for microplastics coming into the aquatic environment, and those are all mentioned here. But most of all, they are coming through direct discharges, either point sources from industries or wastewater treatment plants, and you will hear more about that during the course of the day. But it is important also to remember about aerosols and atmospheric deposition that still makes an addition to the total load. What is also important to say, and that is quite an obvious fact, is that the further we develop our society, the more we have chemicals around us, and the more we actually have the problem of micropollutants. So micropollutants follow the economic growth. And this is demonstrated by these two diagrams. So we do see the constant increase of the number of chemicals that are registered in CAS registry. And we do see or foresee the sales value of chemicals being introduced every day, basically. So what is the scale of this pollution? This is also important to remember. And as I said, one of the biggest pathways that is believed to be is urban wastewater treatment plants. And right now in the region, we have around 3,000 urban wastewater treatment plants of different sizes. And those are presented on a map on the left-hand side of the slide. And as you can see, these are different categories. Most of them perhaps are not that big. So they are from 10,000 to 100,000 PEs, people equivalent. However, we have also big ones. But what is the inputs? What are the discharges from those wastewater treatment plants? Well, what you can see as a diagram, as a pie chart at the bottom of this picture, is that it's just a snapshot. It is not very precise. And this is done based on the results of the analysis of just 5 big wastewater treatment plants where over 300 different chemicals were analyzed. But what you can see according to this pie chart is that most of these micropollutants are industrial origin. However, what you can also see is that quite a big chunk of that are pharmaceuticals and hormones, as well as household and personal care, like cosmetics, what I said already. And then we have pesticides and other different kind of synthetic organic pollutants. What is also important to see is that because of this big share of urban wastewater treatment plants generating the load of micropollutants to the Baltic Sea, we also can rather easily address it. And this is demonstrated on the right-hand side, and both of those diagrams are coming actually from Stockholm University Baltic Sea Center. And they have quite a lot of good policy briefs also on the matter of micropollutants. And what you can see is that, in fact, we have 45 largest wastewater treatment plants located within the coastal area of the Baltic Sea. And just addressing them, we can reduce, well, quite a lot. We can actually reduce more than 50% of the total load of micropollutants being discharged into the Baltic. However, this is not only the matter related to large wastewater treatment plants. For sure, for them, it is easier because they have bigger capacities, they have more resources to do the work. However, the small plants also matter, and they, as I said before, they are more numerous. Why it is important to address micropollutants? This is also very relevant and valuable piece of knowledge. And I also call and draw your attention once again to various knowledge and competences available and information available from Stockholm University Baltic Sea Center. And I actually linked here the Baltic breakfast related to micropollutants in wastewater. So why it matters? And in general, when you think about micropollutants and all those substances that I referred to before, you basically can see several of the specific environmental impacts, like endocrine disruption, for example, and because many of the micropollutants act as endocrine disruptors, and those are not only hormones or pharmaceuticals being discharged, both human as well as veterinary, but also different kind of other, especially persistent organic pollutants. And they are affecting reproduction and development in aquatic organisms. The second issue is bioaccumulation. And as we all know, many of the pollutants tend to accumulate in the food chain, and they are endangering aquatic wildlife and predators, including humans being on the top of the food chain. In many cases, of course. And then the third one is acute and chronic toxicity. And toxic effects can be immediate or long-term, causing malformations, for example, diseases and mortality in sensitive species. But these three are not really something that we should be only worried about, because what is important is that when you mix all those different substances, they tend to transform. Either they tend to transform through wastewater treatment plants because we have biological treatments there and there are different processes that are undergoing there, and different synthetic substances may actually either split into different metabolites, or they can actually converge and resynthesize either in the bioreactors of the wastewater treatment plants or in the actual natural environment. So what is important is actually cumulative effect or cocktail effect, when all those substances with different harmful features and different harmful characteristics mix together, and they actually produce this cocktail effect that can, together, different substances can affect living organisms in a different way. And this is just one example of how this cocktail effect may occur. So different substances coming from different sources, one as a pesticide, the other one as an antibiotic from wastewater treatment plant, and the third one is, microplastic can be discharged from different sources, either deposited from air or coming from the wastewater treatment plants, and per se not being an active ingredient can carry those hazardous substances to the organisms in the environment. And therefore, it is important that regulatory framework actually addresses risk assessment of those priority compounds and various substances that are characterized as micropollutants. Yeah, and then coming to the legislative advances and legislative development. Many of you perhaps know and remember the Silent Spring. That was a very important book, which was popular, well, I would say perhaps in 60s, 70s, but also 80s and 90s. At least it was very well pronounced, being one of the bestsellers, generating people to think about environmental situation, environmental conditions, and the need to change. And that was about pesticides. That was about pesticides affecting birds. That an author suddenly realized that there are no singing birds outside. And that actually boomed and boosted the development in the environmental field, leading towards elaboration of respective environmental regulations. And as you can see on this diagram, from top to the bottom, different types of environmental legislations were occurring. I will not list them all. You can read that through yourself. But what is important is also that in the beginning of 80s, actually, that spurred the development of European legislation. And that occurred quite at the same time as the Baltic Marine Environment Protection Commission, or Helsinki Commission, also started looking into hazardous substances and harmful substances, and not only oil, but also other substances that are coming mostly from land. And that was also quite coinciding with the developments of the international frame, with various conventions coming up. But what are important ones that are highlighted here are the REACH legislation, and I will come back to that in a minute, and also, well, the consideration on how to address cocktail effect, how to address the cumulative risks and cumulative impacts. So what is going on at European scale with regards to micropollutants? And well, I'm rushing through because, well, I don't have that much time. What is important to mention is, of course, the three big legislation pieces, and that is Water Framework Directive, setting standard for water quality and mandating European states to protect and improve the quality of water bodies. And one of the important parts of that is chemical status. So it's not only biological, but of course, biological status is very much interconnected, because the better is the chemical status, the better is also partly biological status of the living organisms. The second piece of legislation is REACH, and that is the legislation that controls and uses the release of chemical substances. And the third one is it's either called Priority Substances Directive or Daughter Directive, because it's connected to Water Framework Directive. And at least substances that must be monitored and controlled in surface waters, including certain micropollutants. And that is constantly updated also, which is important to mention. But what is also important to remember that in general, the EU legislation that is dealing with micropollutants is based on the principles of control at source and polluter pays principle. And why it is important is that at any point, well, the polluter should be taken liable for what is discharged. And this is what is also now taken on board in the new development of Urban Wastewater Treatment Directive. That is for most perhaps important also for this webinar, but in general for addressing not only traditional and conventional discharges of various contaminants from urban wastewater treatment plants and from municipalities, but also micropollutants. And as many of you know, perhaps the directive was revised and it was updated and released in November last year. So we have the link here. And I will not talk about all of it. I will only concentrate on what is in it regarding the micropollutants, and that is a very progressive part. In fact, that was very well awaited, and many of the actors that were dealing with the revision of the directive were coming with their feedback and with their consultations and asks to the Commission and to European Council to really address micropollutants in the revision of Urban Wastewater Treatment Directive. So what is set in the directive is that now it mandates the implementation of advanced treatment or quaternary treatment technologies to remove micropollutants from wastewater, especially in large urban areas. So the new directive requires the removal of 80% of micropollutants among the list of 13 substances. And well, you see the red substances listed at the bottom of the right-hand side. I will not talk about them. So it is requested that 100% of large wastewater treatment plants over 150 people equivalent, 150,000 people equivalent, should have this quaternary treatment by 2045. And of course, it is a gradual process with steps in it. What is also important is that besides a stricter monitoring and reporting on what are you discharging and how you are discharging and what are the technologies applied, producers of pharmaceuticals and cosmetics are held liable for what they discharge into wastewater streams, because it is believed that 92% of micropollutants that are discharged through wastewater treatment plants are coming from those products. And therefore, the extended producer responsibility scheme is introduced in the revised wastewater treatment directive, exactly pointing to the polluter pays principle. And that means that the producers of those substances are required to cover 80% of the additional, at minimum 80% of additional costs of this quaternary treatment. Of course, we will see how it will work, but this is at least a setting that we have in front of us. And then, well, I don't have actually time to speak about that. But what is also important to mention is that you do not necessarily need to have this sophisticated treatment technologies that you will hear later in the course of the day. But what we have as civil society presented is that you can use constructed wetlands as some kind of a, well, if not calling it quaternary treatment, but at least an additional tertiary treatment. Especially this is really relevant for smaller wastewater treatment plants. And what we have demonstrated in the study that was actually presented to HELCOM already, I think, in 2020, is that with constructed wetlands, you can also trap micropollutants quite effectively. But again, as I said, I don't have time for going through it. Nevertheless, what is also important, we were talking about Urban Wastewater Treatment Directive and others, and those are unfortunately still end-of-pipe solutions and end-of-pipe technologies. What is important to think about is the whole cycle in order to actually address source, reduce at source. And this is presented in this diagram that I have taken from, well, other study. And that includes the whole circularity cycle. So you have to rethink the design of specific articles, for example, in order to ensure that hazardous substances are not included in there. You have to rethink the whole manufacturing and distribution and the use cycle of it. You should, of course, remember about designing it for recycling and for reuse as well. But again, so it is important to look not only at the end of pipe, but also very important to look at the source. Thank you very much. I tried to rush it through, and in case you have any questions, you can always reach me out. And these are just few of the hazardous substances projects that we are working with and involved in from Coalition Clean Baltic. Thank you very much.
Thank you very much, Mikhail. Thank you very much indeed for this very good introduction to the topic. And I would just like to mention that you showed there in your last slide the HASGON transfer project platform, it's called. So also the UBC Sustainable Cities Commission is a proud partner of that project, just starting this summer. And I would also like to mention that you referred a couple of times to HELCOM, and you even mentioned the stakeholder conference from 2020, was it? So next Monday it will be this year's edition of the HELCOM stakeholder conference, and it has a focus on hazardous substances, and EMPEREST is a partner organizing that event. So yeah, very many points in common, but yeah, thank you very much for this. And please, everybody, feel free to add your possible questions and comments in the Q&A box. And I see we already have one question there. Maybe we have time to quickly go through this. So the question is, could you dive deeper into the implementation of the EU Water Framework Directive? Is it? Yeah, in the Baltic Sea region. How many treatment plants will have to be upgraded? Will the biggest plants be upgraded primarily? Well, this is quite a big question, but I guess it was referring actually to the Wastewater Treatment Directive. So yeah, quite many plants will have to upgrade.
Well, you will find actually a very good snapshot of the situation with wastewater treatment plants in the region that was presented by Stockholm University Baltic Sea Center. And basically, that's what is mentioned there. We have, I think, around 45 large or relatively large wastewater treatment plants located within 20 kilometers coastal area of the Baltic Sea. And they are discharging 70% of all wastewaters to the Baltic Sea. So by addressing even just those, so 45, that would already increase and improve the situation with the discharge of micropollutants into the Baltic straight away. But there are plenty of smaller plants. And in fact, well, the revised Urban Wastewater Treatment Directive requires mandatory quaternary treatment for the plants over 150,000 PEs. But the smaller plants from 10,000 PEs up to 150, they are also required to look into that and introduce quaternary treatment, but based on the risk assessment. So especially those that are located within the areas that are so-called sensitive to micropollutants, they will have to introduce quaternary treatment as well. I don't remember exactly the date. I think it is probably also by 2045, or as I said, it is a gradual process. So it is 2036, I think, the previous step, when like 65% of all the plants should be upgraded. And then 45 is just the ultimate deadline.
Yes, thank you very much indeed. So the link you mentioned was Stockholm University publication. Yes, yes. Thank you very much for this. And this makes a very nice bridge to the next presentations, because indeed it is because of these upcoming requirements that we have built these mobile containers in EMPEREST, so that we can test and share our experiences and results with all those plants who will have to do investments in the near future. So our next speaker is Associate Professor Taavo Tenno from the University of Tartu in Estonia. The floor is yours.
Hello. Yes, thank you for nice words, and Mikhail made a very good bridge or introduction to the topic. So the wastewater treatment plants of considerable size, over 150,000 population equivalent, have to do the actions. They have to do some kind of quaternary treatment, and this is was focus of our project, EMPEREST. And as Lotta said, EMPEREST started 2023, so it has been running already more than 2 years. And what was the focus, or what is the focus, is more micropollutants and micropollutants from the wastewater treatment plants. So we, as the major part of the EMPEREST project, is focused on PFAS micropollutants, parent fluoroalkyl substances. This particular part of the project, which is more focused on the wastewater treatment plant and on the technologies, considers both parts. So organic micropollutants, which are majorly pharmaceuticals and hormones and other like cosmetics and industrial chemicals. And when we started 2023, there were no really very focused line for that. So we had predictions what will be the urban wastewater directive, and we had there is a huge amount of different pharmaceuticals, different chemicals which are called micropollutants altogether, and with the urban wastewater directive from November 2024, last year's end, so we have a more framed amount of marker compounds of this very fused different kind of pharmaceuticals and micropollutants. So we have at least limited it to it. And unfortunately, our project was running already before, so we do not have very strict analysis platform, analysis stream. So we have run a little bit different in different occasions, what we'll show also today. But we are focusing on also on organic micropollutants as general. But major focus and the other focus is PFAS substances, and these are called forever chemicals. They are not in this latest version of the accepted version of the Urban Wastewater Treatment Directive. However, PFAS has a very potential or very forever or very unbiodegradable. They are not treated in the wastewater treatment plants normally, so they are one of the biggest environmental challenges in the Baltic Sea region. So they were also parallel studied and in the perspective of wastewater treatment plant technologies. And what we are doing, we are now focusing on part of the project, which is objective output 3, which is technologies of wastewater treatment plants. So we know that bigger wastewater treatment plants have to do something. They have to make quaternary treatment, and that project part is to facilitate those treatment plants to choose the right technology. This work package is delivered by or directed by University of Tartu. That's the reason why I'm talking about it. And this is we decided to make 2 container-size wastewater treatment plants. These are a little bit of a semi-technical size. They are not really big, but they are considerable to see the effect. And there were 2 pilot plants created or constructed, and each of those pilot plants had 3 to 5 different technological solutions, which are known to work for to be a potential candidates of the quaternary treatment. So one pilot plant was erected in Tartu, and another one in Gdansk, Poland. Tartu is in Estonia, so they are a little bit different. However, they were tested first in Tartu, beginning of 2024, then in Tallinn, and the other one was in Gdansk and in Szczecin. These are already done, those tests are done, and now the pilot plants has moved to Kaunas and the other one respectively to Turku, and those tests are still ongoing. So that's the reason also we are presenting a little bit of preliminary results, of the preliminary view of our project results. So, and now I'm introducing our talkers or our speech, who are talking today. I'm Taavo Tenno. I'm from university, and from Tallinn work, Marlen is talking about experiences. I talk a little bit about the results of Tallinn and Tartu, so the pilot plant which was created in Tartu. And the other pilot plant, which is a little bit different, I talk about, was constructed in Gdansk, and Marek from Gdansk Water Utilities is talking about the technology of this pilot plant and Gdansk results, and then Piotr will talk about tests done in Szczecin. So what technologies are there? So for the quaternary treatment, there are very many different technologies proposed on the different levels of reliability, and there are sequestration technologies and there are transformation technologies, just categorized. And there are sorption, and the most prominent sorption technology is activated carbon. So we know that activated carbon absorbs different micropollutants, and there are different ways of different porosities and so on, the different types of activated carbon. And so in general, there are two different. So granular form of activated carbon, which is a big size. So normally it's like a fixed bed, and another one is a powdered version. This needs to be separated. But the main idea is sorption, and it absorbs different chemicals, including micropollutants. So finally, we have some kind of activated carbon filled with those chemicals. And for transformation technology, the most abundant, the most prominent, and most used is ozonation. Ozone cracks the organic micropollutants, makes them more biodegradable or more sorptive. So usually ozone is expensive. It's not given in a dose where it degrades everything, but it's just makes it more biodegradable or makes it less harmful. It's usually in combination with some biological activity or with activated carbon, for example. And there are also other technologies which were also included in the test, like nanofiltration. Nanofiltration cuts the size of it's a filter. It's not very expensive, as expensive as reverse osmosis, but it cuts the size of, it's more directed against the PFAS. And also anion exchange design, and anion exchange is also towards the PFAS removal. And when we compared our treatment plants, or our pilot plants, so granular activated carbon technology was in both pilot plants, and ozonation was in both pilot plants. And there was a little bit different. So Tartu pilot plant had also option for powdered activated carbon and nanofiltration, and Gdansk treatment plant has anion exchange design. A little bit more in those pilots. There is also a pilot loss medium filtration to eliminate all the solids which escape from the final clarifier of those treatment plants, so that we wouldn't lose ozone or activated carbon for the solids which come from the wastewater treatment plant. And there is also disinfection in the end of the process. And the other pilot had a little bit more or less the same parts, including pilot loss media filtration and also UV, but there are some small differences as I explained. Ion exchange was for Gdansk, and micro powdered activated carbon and nanofiltration was in Tartu pilot plant. So this is a Tartu pilot plant. Marek will talk about the Gdansk, and now continuing only with Tartu and Tallinn experiments and the tests. And the pilot, is quite technical. It's sufficient to see the effects, but it really doesn't show it shows the efficiency, but not really the cost effect, because the size factor, we cannot really evaluate capex and opex directly based on the pilot. But to see the really preliminary results, and I also brought out few of the results in order to make it more easy to follow. So I choose organic micropollutants. There is a corrosion inhibitors, benzotriazole, and two drugs, diclofenac and metoprolol, which is anti-inflammatory, painkiller, and cardiovascular. So you understand what we are talking about. And wastewater treatment plants, because those come from the drugs come from the hospitals, from the households. So they are quite one of the most high values of those drugs, for example. And they are in microgram scale, so they are not in nanogram scale usually. And you can see that the ozonation, granular activated carbon, and activated carbon in powder version works quite well with in the case of Tartu for those drugs, and also in the case of Tallinn. Tallinn didn't do the nanofiltration experiment, but in Tartu we can see that nanofiltration really doesn't work for those organic micropollutants, or works with less efficiency. And if you go for the PFAS, then it gets a little bit more not complicated, less potent. Those ozonation, granular activated carbon, and other activated carbon didn't work very well with the PFAS. So you can see the mild degradation. It can be up to 60–70%. But it wasn't very, and if we look what we are looking, this is the most abundant specific perfluorooctanoic acid and perfluorooctanosulfonic acid, which are most potently shown, and they are most also adverse effect of the humans, which has, and the last component here is sum of all observed PFASs made as P4 equivalent, and 24 PFASs have been measured. And you can see that really nanofiltration, which you can not see here, works perfectly. Influent high and no effluent. And in Tallinn, the results were a little bit different, maybe a bit less potent, but about the same. So from the conclusions of my part, that technologies alone work generally for the organic micropollutants, not nanofiltration, out of those which were tested. Absorption technologies have a mild potential effect on PFAS removal, but nanofiltration had very high effect. Long chain, I don't show, but we observed that long chain PFAS may partially degrade during ozonation, and this should be considered in monitoring and assessment. That ozonation affects also PFAS, but it makes it a little bit trickier to analyze. And we need feasibility studies for investment decision for those wastewater treatment plants. So this is all from my side. So we continue with Tallinn now.
Thank you very much, Taavo. And yes, Marlen, please go ahead right away.
Hi, everybody. Thank you for the introduction from Taavo. I'm here to give you a brief overview of our work with the pilot plant in Tallinn. So yeah, the pilot plant arrived from Tartu Wastewater Treatment Plant on August 26, 2024, and we operated it from September 2nd to February the 3rd, so about 6 months. And before that, Tartu had already operated it for about 6 months as well. And when the pilot arrived, we decided that the pilot's influent would be the biofilter in our plant, because the water quality there is already good, because it's the last biological treatment step. And in the future, when a fourth treatment stage is added, it will be combined with the water exiting the biofilter. In average, the inflow to the pilot is about 1 cubic meter of water per hour. This changed when ESPAC arrived, but I will talk about it a little bit later. A little bit about the treatment process. So it begins with a drum filter, which is in a separate container and helps to reduce this turbidity. This is followed by ozonation, then a sand filter, and 2 granulated activated carbon filters, and also UV. So initially, we used 2 consecutive granulated activated carbon treatment stages, but in November, we made a small system modification, connecting one of the carbon filters directly to the drum filter. And this adjustment allowed us to create kind of 2 last final sampling points, giving us a better understanding of ozonation effectiveness and if it's even needed. So in January, we had the opportunity to test ESPAC, or this superfine powdered activated carbon. which we added between this biofilter and drum filter. To do this, we had to prepare a special chemical mixture consisting of water, powdered activated carbon, and our coagulant, which is iron sulfate. This preparation and dosing of this mixture was a very daily task and required a lot of time, and all of my clothes are still dirty of this carbon. But we completed the SPAC tests in about a week, after which it was sent to Tartu Wastewater Treatment Plant for further testing. And in the picture, you can see how the water is black and out comes this beautiful clear water. Regarding the sample collection, the pilot plant itself has an on-site analyzer that takes samples every 15 minutes automatically. And this was very helpful for continuously monitor this pilot's effectiveness. And for PFAS and pharmaceutical analysis, we used the Eurofins labs. And even before this project started, we had already done PFAS analysis before. So we had a pretty good idea which substances were an issue for us. But for pharmaceuticals, this project was very helpful for us because we didn't have that much data before. So we took a broad approach covering the wide range of compounds, and now we know what to focus on in the future. And currently, the pilot plant is already, like Taavo said, operating in Turku Wastewater Treatment Plant. And I think their sample collection has already begun. So in a few months, it will be very interesting to see how their samples are gonna come out of, because Tallinn and Tartu are both outside plants, but Turku is inside, so it's a little bit different, but hopefully we'll hear some good news. And thank you. If you have any questions, I can answer them, or you can write to me.
Thank you very much, Marlen. We are a bit behind the schedule, but would you and Taavo have like a max 1 minute reply to this question that we have, that why are the results from Tartu and Tallinn so different?
I can answer that Tartu and Tallinn are very different plants. The population is even different. The water incoming is very different. Maybe Taavo can talk more about Tartu.
We didn't give really very strict way how to conduct the tests. The treatment plant had their own strategies, and the data, what they showed, are a little bit with different dosage, and that's the reason why you could see also a little bit differences in the efficiencies. However, what also few of the technology delivering companies said that the technologies, since the technologies in the wastewater treatment plant main process are different, especially Tallinn is using biofilm as a latest or the last stage of a wastewater treatment plant as a denitrification biofilter. It's possible that absorption technologies like powdered activated carbon and granular activated carbon are a little bit shaded. So there are a little bit more pieces from the biofilm which are interfering a little bit with the absorption technologies. But still a little bit is as a speculation from my side at the moment.
Thank you very much for this. Thank you, Taavo. Thank you, Marlen. And our next speaker is then Dr. Marek Swinarski from Gdansk Water Utilities. The floor is yours.
Good morning, everyone. Thank you a lot, and Taavo, for introducing me to the audience, so I can start my presentation. I'm very pleased I can tell you a few words about pilot plant which was constructed by the company I work for, Gdansk Water Utilities, within the EMPEREST project. This semi-technical pilot plant is dedicated to evaluating the removal efficiency of micropollutants from water by advanced treatment technologies. The pilot plant was commissioned almost a year ago in May 2024. Today, after testing the plant in field conditions during summer and winter time, after successful completion of pilot studies at 2 wastewater treatment plants in Gdansk and Szczecin in Poland, and another trouble-free operation at the Kaunas wastewater treatment plant, I can confidently say that we have developed a state-of-the-art solution. We have developed a tool that can be used by numerous wastewater treatment plants or water treatment plants operators to evaluate the efficiency of micropollutant removal by means of advanced treatment processes. I want to say that this success would not have been possible without excellent cooperation with the contractor, Probico Aqua Company, during the whole construction time of this pilot plant. As you can see in the pictures, the pilot consists of a single 20-feet container that houses all the units that make up the entire process train. This makes the pilot plant, I would say, ultra-mobile, as it can be easily transported to any location to carry out pilot studies. It is also a plug-and-play type pilot plant, as it can be quickly deployed on site. The process train has been designed to be highly flexible, allowing for testing different wastewater treatment configurations or testing the selected individual processes, depending on the research needs. All the equipment used is of high quality, with most devices being those commonly used in full-scale facilities, making the pilot plant highly reliable. The photos at the top of the slide show the pilot plant installed at the wastewater treatment plant in Gdansk. The bottom photos you can see show the plant being loaded onto a truck and transported from the wastewater treatment plant in Szczecin to the Kaunas plant. This is the view of the control panel, showing the first part of the process train consisting of the suspended solids removal system and the ozone oxidation system. Suspended solids are removed in the Mita cloth drum filter of the maximum capacity of 20 cubic meters per hour. Ozone is produced on site from ambient air using the Pro-O2 oxygen concentrator and the Ozonia compact ozone generator of the nominal ozone production 55 grams per hour. The oxidation process takes place in the contact tank with a maximum working volume of 800 liters. The working volume of the tank is adjustable, allowing for contact time settings from 15 to 40 minutes. Ozone is dosed to wastewater via injector into the recirculation loop of the contact tank based on the set ozone dose and wastewater flow rate. This slide shows the remaining part of the process train, consisting of 2 gravity granular media filters of the diameter 35 centimeters, which can be filled with various types of filter media. The filters can be operated in parallel or in series. The filters are backwashed with treated wastewater using the backwash pump and with air using the air compressor. The backwashing process is carried out in the same way as it is in full-scale facilities. The last part of the process train is the Probico Aqua UV lamp of the maximum flow 700 liters per hour and UV dose of 400 joules per square meter at 60% UV transmittance. The pilot plant is equipped with several online measuring instruments, the BNT ozone analyzer to measure ozone concentration in gas produced by the ozone generator. This analyzer allows for automatic control of ozone dose to wastewater. The Evoqua ozone analyzer to measure ozone concentration in water in the effluent of the ozone contact tank. There are also 3 online WTW UV absorbance probes in the effluent of the drum filter, ozone contact tank effluent, and granular media filter effluent. And 2 WTW turbidity probes to measure the concentration of suspended solids after cloth filtration and granular media filtration. There are also 8 water flow meters and 1 air flow meter, and 8 water level sensors in all process tanks. PLC-based control system and human-machine interface enable monitoring and control of the devices and processes within the pilot plant. On-site router provides secure remote access to the pilot plant over cellular networks. Results obtained from the pilot studies can serve as valuable guidelines for designing full-scale quaternary wastewater treatment systems. This slide shows the removal efficiency of pharmaceuticals by ozone oxidation alone for ozone dose of 1 gram of ozone per 1 gram of dissolved organic carbon and 30-minute ozone contact time. The removal efficiency observed ranged from 61 to 100%, depending on the compound. And here you can see how activated carbon applied after ozonation enhances the removal of pharmaceuticals. For ozone dose of 1 gram per 1 gram of dissolved organic carbon, 30-minute ozone contact time and 20-minute empty bed contact time of activated carbon filter, the removal efficiency varied from 94 to 100%. This is the end of this very short story about our pilot plant. So thank you very much for your attention.
Thank you very much, Marek. Thank you very much indeed. And there is Marek's email address. If you have some questions you would like to address directly to him, please go ahead. And also please don't hesitate to use the Q&A box you see in the bottom of your screen. We're running a bit behind the schedule, so I will just directly give the floor to the manager of Pomorzany wastewater treatment plant in Szczecin, Poland. So Piotr, Miakoto, the floor is yours.
Yeah, thank you, Lotta. Thank you, Marek, for describing the plant. I will go with a few words how it went on our plant. First of all, the installation of the plant. It took us about 30 minutes to unload it from the truck, to level it and to position on the station. And then the following day to connect all the media, electricity and wastewater, and the plant was ready to operate. So it's really easily to load out, load in, and plug in and start to operate the plant. Okay, after receiving the pilots, we decided to follow the new EU directive, and among the others, we concentrated on the 12 pharmaceuticals that are defined in categories A and B, or the first one containing 8 pharmaceuticals, the second 4, as you see on the left side. And we had only less than 3 months for the test, so it was really a dense period. We decided to prepare and to make 9 samples, which occurred later that we did 2 additional, during which we tested 2 different granular activated carbons And each series of sampling, we did different dosage of ozone, different contact time for ozone, and different time for contact of GAC. Okay, as Marek mentioned, the pilot uses drum filter, ozone, and GAC. And it was, yeah, very easy and very nice experience actually to operate this. Well, we can go to the final slide with the conclusions. Okay, now this will be more on this slide. On the right part, you see the 3 diagrams of micropollutants of pharmaceuticals actually. And you see the actual values, the inlet to the plant, the very top right one. Then the middle one is the effluent of the plant, which is also the inlet to the pilot. So you see that the current reduction of those pharmaceuticals is at the level of about 40%, you can say. It differs from different substances. And after the pilot, you see the reduction is actually complete, which also confirms what Marek tested at his plant in Gdansk. So now to the conclusions, the 3 major points. The test of this EMPEREST pilot proved that we actually have the some technology for fulfilling the requirements of the EU Wastewater Directive, which because it is actually the same technology as we use currently for the drinking water. The second main conclusion is, well, we need the implementation of the EU directive, and we see it may be a little bit difficult to introduce the polluter pays principle, because, well, the companies are not evenly distributed throughout the countries. It will be difficult to tax them, and you have to have this within the middle of 27. Yes, it has to be designed, and because the national implementation is to be finished by that. And following this, the last conclusion, which is the most important, is the money and the workforce that will be needed to implement this. Well, in our case, in Szczecin, we need to purchase new land because all those investments require a lot of area. We need to develop the tertiary treatment stage because the new directive also reduces the allowed values for phosphorus and nitrogen. We have to construct the new quaternary stage, and we need to fulfill the requirement for 100% of energy neutrality. This will require a lot of money. In our case, it will be, we estimate it will be about 70 to 80 million euro, of which only part will be theoretically covered by this polluter pays principle, which is only for the quaternary stage. And then we heard it in the first presentation. There will be a lot of wastewater treatment plants having to introduce this within the very limited time. So the workforce will also be scarce and needed for this investment. Yeah, thank you very much. That was all from me.
Thank you very much, Piotr, and very interesting conclusions indeed. A lot of questions in the air, but everybody's now a bit familiar with the EMPEREST pilot plant concept, and you will be able to read our full results in a report that we will publish soon after summer. So we will publish a document compiling all of these experiences and results of the laboratory analysis and so on. Thank you very much for the speakers so far, but now it's time to move on. So our next speaker comes from the German Association for Water, Wastewater and Waste, the DWA. So Vanessa Ingold, please, the floor is yours.
Hello, thank you very much, Lotta. Yeah, so hello everybody. I'm Vanessa Ingold from the German German Association for Water, Wastewater and Waste, DWA, and from the Regional Association Northeast, which is also part in the EMPEREST project. And I will talk about the training materials that are developed in our project. And I'm going to introduce a little bit what this is. So the training materials that we built within our project are there to increase the capacities of water utilities and cities. So we want to share the knowledge about micropollutants, but especially about PFAS with people working in the infrastructure, the water infrastructure and public service, and also within the local authorities. So what is our goal? So we have this thing about micropollutants, but especially about PFAS, that it is a new topic. And we think that if we want to efficiently address the PFAS issue and also implement solutions successfully, we have to raise awareness, and especially among the stakeholders, which in our opinion are the water utilities and the cities. So we developed within the project tailored training materials and tools for these target groups. And I'm only presenting this work now. The main leader of this work is the Technical University of Berlin. And we are also, of course, part in it. But now, what is the content of the training material? So we developed material based on videos from expert presentations and interviews from our own project. So we had workshops within the EMPEREST project and events where we filmed these presentations and made short videos out of it. So we have short versions about different topics concerning micropollutants and PFAS, but also we have the full presentations, of course. There will also be some explanatory concise texts about which topic we want to address with these videos. And also there will be additional links for more information if somebody thinks this is really interesting and wants to learn more about it. These videos are presented in English, but we think that it is very important if we want to address our target groups that we also use local languages. So we added subtitles to all the videos in local language. What is the topics that we are going to address in the training material and the structure? So first of all, we want to introduce what is PFAS. There we have the topic production and use of PFAS, but also PFAS release into the environment, emerging health and environmental concerns, and some information about the chemistry and the properties of PFAS. Then in the next chapter, so to say, we want to address environmental fate and occurrence. So what happens in the environment with PFAS? But also the sampling is a very important part. So where to take samples and how. And of course, it is not like something special about PFAS, how to sample, but more like how to do the sample properly in general with water samples in the environment. Then there are information about analytical methods to determine PFAS. In the next chapter, we just heard it also in the revised Urban Wastewater Treatment Directive. There will be the need for risk assessment in the future, and we want to make an introduction about this risk assessment. What does it mean? And also in the EMPEREST project, a risk assessment plan has been developed from the city of Riga and other partners. And we want to introduce this tool and how to use it, and how you can use it in your communities or in your local authority, for example. Also, there will be an introduction about what we just heard about regional and national policies. There was also a question about it. So regulations from the EU they have changed, and is also like ongoing changing about micropollutants. And this again is different in each country in the national law. And there is a little bit of an overview, like what is the situation regarding this. Then in general, we hear about PFAS and wastewater and advanced treatment technology for removal of PFAS and other micropollutants. And last but not least, as we just heard today about our pilot containers, there will also be an introduction about which technology was used, how the operation works, and what results did we get from these pilots. Where you can find this training material. So this will be hosted on the Baltic Smart Water Hub, and the web address here, Baltic Water Hub, you can see below. And this is how it's going to look like. And I want just to show how you can actually use this training material that we want, that we produce, because we really want it to be used by our target groups. So you come to this Baltic Smart Water Hub, and then you find here training. In the next side, you will see this, and down in this button, you find training package on PFAS and other micropollutants in wastewater effluents. If you click there, you come to this site, and if you scroll down, you find all the chapters that I just introduced in a like a very nice and also comprehensive way. So there are also a lot of pictures, of course. I just introduced the structure and like in a very dry way, maybe, but of course these will be videos and very nice and easy to access. This first part is actually already available. So if this webinar finished, you can just go and look at the Baltic Water Hub and check it out. And yeah, of course, give us some feedback on what you think about it, if it's useful, and yeah. So we have this training material, but we also want to transfer it and to disseminate it. And for this, the Turku University of Applied Science and us, the DWA, is responsible in the project. So we make a lot of promotion and advertisement in events of the EMPEREST for this training material, but also in local events in the BSR countries. So you might also find it in other events that you maybe participate from our project. Also, we will transfer the material to umbrella organizations in the BSR countries. So that would be other water associations or water utility associations on a national level. And maybe, yeah, if you're a member there, you will maybe also get information from them about our training material. And the Turku University of Applied Sciences will launch a social media campaign. So if you follow us on Facebook, Instagram, or LinkedIn, you might also learn about our training material, but in general about micropollutants and PFAS a lot. Okay, yeah, this is it from my side. I'm very happy to get your feedback on the training package, but also other yeah, advices or hints about it. So if you want to contact me, this is my email address. And yeah, thank you very much for listening.
Thank you very much, Vanessa, indeed, for presenting the training package. And I would also like to warmly invite everybody to take a look at the training material and spread the word. If you know people or organizations who might find this useful or who might be in need of such materials, please just pass on the link and tell people that this actually exists. It's openly accessible and everything, so easy to use. Thank you very much, Vanessa. And now we're moving on to our last speaker, who is Mariia Andreeva from UBC Sustainable Cities Commission.
Thank you very much, Lotta. Yes, for the last closing words, first of all, thank you for all of the enlightening and really inspiring presentations and a lot of interest from the participants. And before you leave, we also have some offers to make this a proper full package, because now you've heard a lot about what EMPEREST offers. So what are also the interaction opportunities that we offer? So yes, Vanessa has just introduced the Baltic Smart Water Hub, the portal which was developed in the UBC Sustainable Cities Commission some years ago. So we administer it from the UBC side, and this is also this is not only an EMPEREST tool, this is also our support tool for all of the local stakeholders in the Baltic Sea region. So your organization, your projects are very warmly welcome to make use of it. You can at any point share your good practices, technical solutions, innovations, tools with the rest of the region. And by doing so, you will emphasize your local achievements, and also this would make possible for others to test really interesting water solutions. For example, these technologies that you've heard about today, once we finalize all of the testing and piloting, we would also publish these results, very concrete results, in the Baltic Smart Water Hub. And as you just saw, we also launched this separate space for trainings. This is a new feature for the hub. The EMPEREST training package is being uploaded there now. And we're also happy to invite other experts and other projects to share their also other capacity building materials, if you have them, when it comes for the whole water sector. So this is the space to interact further and exchange with the water experts in the Baltic Sea region. Then EMPEREST is on its way to publishing the outputs in the middle of this year. And today you heard a lot about technological pilots and capacity building tools, but we also worked with this strategic document, which was just published this month by HELCOM, and we invite you to read this. This is the methodological recommendations for the monitoring and assessment of PFAS in the aquatic environment. This document outlines which PFAS substances, which species should be selected for the monitoring, what are the parameters to take into account, and it also includes the assessment of PFAS pollution in the Baltic Sea based on the large data call that was done over these years. But you will hear more about this exactly next week at the HELCOM's stakeholder conference, so we also invite you there. Plenty of places to join. And last but not least, the EMPEREST project will also have the 4th international workshop in Szczecin in May. So we also warmly invite you to the workshop Unlocking Innovative Solutions and Developing Capacities in the Wastewater Sector. So registration is open until the 25th of April, so you have time to plan your travels and register and join us. And we will continue there discussing how can we possibly fulfill the Urban Wastewater Treatment Directive and how to make this in the most efficient, effective way for all of the plants, but also other local stakeholders. Follow our channels, newsletter and LinkedIn are there so that you never miss any news from us. And yes, that's it from me. So back to you, Lotta.
Thank you very much, Mariia, and I hope everybody will consider joining our events and consider taking a look at our results and our solutions. I think it's time to wrap up this seminar. Thank you to all speakers. Thank you so much for very good and very inspirational talks. I'm sure everybody in the audience learned something new from this. Thank you to everybody for joining today, this webinar. And I hope to see you sometime soon again in one of the EMPEREST meetings and events. So thank you very much, everybody. And I would just like to finish by showing you when we will have our next UBC Talks webinar. So in 2 months, you will be able to hear about biodiversity, increasing biodiversity in urban settings. So you are most welcome to join that webinar also. Thank you very much, everybody, and have a nice day. Bye-bye.